Start working with increasing, decreasing, even, and odd functions. The idea of an increasing function is fairly easy. And we're not going to spend forever on this idea, but let's say that I've got a function that kind of does this, then it's flat, and then it does this. All right? And we'll just say, we'll call this point A. Actually, let's come over to the left. Let's not call that one A. Let's call that one B. Call this one A up here. Call this one C. And call this one D. Okay? Doesn't have to be exact. We're just looking at 4 points. Now, common sense would tell you, now remember, we read a book left to right. We also usually read a function left to right. If it's increasing, can you tell me for what x values it is increasing on this little graph? From what to what x values? C to D. Okay, right in here it's increasing. I'm just going to abbreviate, increasing. So, of course, that would make sense then that over here from A to B, it's decreasing. Well, in the middle where it's perfectly flat, which is what I tried to draw with something perfectly flat, this would be constant. Okay, the function, it has a constant value. It does not change. All of the function, when I put this B in, and I get this x value, whatever it is, all of these values across here are the same. Okay? Now the other thing that we need to do though is kind of define what we mean by increasing. If it's increasing, isn't it safe to say, remember this y value up here, isn't this f of d? Isn't that y value up there f of d? Okay, remember we have to start training our minds to be thinking in terms of function values. And this y value right here is f of c. Now, we're not going to write all of this out because it'd take us 5 minutes to do it, but let's just kind of make a general statement here. If it's increasing, all right, if D is bigger than C, okay, and if you look at my drawing there, I think that's true. D has a bigger value than C does. If it's increasing, then f of D is bigger than f of C. Does that make sense? If the function is increasing on a certain interval, then this function value right here has to be bigger than this function value. That makes sense, doesn't it? That's kind of common sense. That's why I said we're not going to write it all out. Decreasing would be the opposite, right? Now, if they're constant, then we could say if it's constant, then I could say that this f of b, I could say that f of b is the same thing as f of c all along here, okay, if it's constant. All the function values stay the same, all right? So what we're going to be, one of the things you're going to be doing in homework tonight is, for example, they're going to tell you to graph and find the intervals over which the function is increasing. I'm going to kind of bullet these, okay? Increasing, decreasing, constant, or greater than or equal to 0. Don't want to leave that one off because I think that's in your homework. They want you to find out all those intervals where that is true. This is a graphing calculator exercise, okay? So let's use this function. F of x equals x cubed minus 3x. All right, there's our function. So let's go to the graphing calculator and get a general idea of what this function looks like. It is x caret cubed minus 3x. There's my function. We get it entered into our y1 screen first. And now I just want to go to the Zoom standard screen just to kind of get an idea of what this function might look like. There it is. It's a little small. We're going to be doing some things with it, so let's close it down. Let's go to our window, and I think probably negative 4 to 4 is plenty big enough on my x's. And maybe on the y's, we'll just close it a little, negative 8 to 8. Okay, now let's look at the graph. There we go, that's a little bit better picture. So this function has got several things going on. Let me just kind of get this to a place to where I can write on it. So I can show you better what I'm talking about. Okay, this function has really a lot of the characteristics we're talking about. What's the one thing, if I'm looking at these 4 bullets up here, what's the one thing that it does not have anywhere? It's not constant anywhere. So we don't need to worry about that one, okay, in this case. But the other ones, it has some increasing, it has some decreasing, it has some places where it's greater than or equal to 0. So obviously, we can see it is increasing here, it's decreasing here, increasing here, okay? So, but we're not done. I'm just kind of drawing on this so that we can get an idea of what's going on. But how about this one right here? Where is the function greater than or equal to 0? Well, what I'm going to do is kind of use red here. This is where the function values, we're talking about function values, which remember are y values, trying to train our mind that function values are y values. So right here, and then right here, right? Those are the places where the function is greater than or equal to 0. Not the x values, where the y values are greater than or equal to 0. All right? So we've got a little bit of work to do. Why don't we take care of this one first while we're talking about it? So if I want to answer that question, it said to find the intervals over which the function is greater than or equal to 0. It's asking for x values. Okay? The answer to this question is going to be which x values give me the y values, all right, where it's positive, where it's greater than or equal to 0. So let's go back to my graphing calculator. And it looks to me like I need to calculate zeros. All right? So I will go to second trace, and we're going to calculate some zeros. All right? I think it's easy to see that one's 0. Let's do this one over here. Left bound, enter. Right bound, enter. Guess, enter. So that 0 is negative 1.73. Okay? Let's keep that in the back of our minds, and let's go over to the other one. Let's calculate another 0. We want to do that other one that's over there. So we need to move this over, move my cursor over until I'm just to the left of that 0. That's good. Hit enter. Move it just to the right of that 0. Hit enter. And hit enter again. So it looks like it's positive 1.73. Okay? So let's go back to my graph now. And now I know, I need a different color. I know that this x value right here is negative 1.73. And this x value is positive 1.73. We just found that using the graphing calculator. So to answer this thing right here, what are the intervals over which it is greater than or equal to 0? Or where is the function positive? Well, it's going to be this stretch in here. So my first answer, it is greater than or equal to 0 on the interval from negative 1.73 to 0. Actually, that should be a square bracket, sorry, because it said greater than or equal to. And we would include 0. All right. Union, it's also greater than or equal to 0 from positive 1.73 clear over to infinity. So I would say union 1.73 to infinity. Okay? Now, we can kill two birds with one stone here on this problem. For me to answer this increasing and decreasing question, I need to find these little points here where they change. Well, those points are called a maximum and a minimum. This little high point right here is called a maximum. This little low point right here is called a minimum. All right? So let's go back to the graphing calculator. All right? And let's calculate those. This is something we have not done yet this year, so watch carefully. We're going to go to second trace again and look at what 3 and 4 are, minimum and maximum. So let's do the maximum first, number 4. Now, this is just like doing the 0. We're going to move my cursor to the left of the maximum, and it doesn't have to be exact, just get it a little bit to the left of it. Okay, right there's good. Hit enter. And then we're going to go to the right of it, and we're going to hit enter. And then once again, we hit enter again because it says guess. So there's a maximum at negative 0.999999. Looks like it's negative 1 to me, doesn't it? Right? But that being said, I'm going to take a screenshot of this, and my other drawing was getting kind of messy. Okay, so I have now calculated a maximum. Now let's go back and find the minimum. Okay, I have found this point. Now we need to find this point. So we go back to the graphing calculator, and we're going to press second trace again. And we're going to select number 3, minimum. And we're going to do the same deal. We're going to move our cursor just to the left of my minimum. Hit enter. I'm going to move my cursor just to the right. Hit enter, and hit enter again. So that minimum is at positive 1. All right. So we've now got plenty of information here to wrap up this problem. Okay. I've got a maximum and a minimum. So if I'm going to put the intervals over which it is increasing, okay, this thing is increasing. What x values? Well, it's increasing from negative infinity clear up to that maximum right there. So it's increasing from negative infinity to, and we're going to round that to negative 1. And these are round brackets because it's not increasing right at negative 1. That's a maximum. Where else is it increasing? Well, it's also increasing from here to here. Okay, because those are also the x values that give me increasing y values. So it is also from 1 to positive infinity. Okay? Where is it decreasing? Well, the decreasing values are what's in between, just right in here. So it's right in between the maximum and minimum. It is decreasing, all right, from -1 to 1. Boom, that part is done. Now, what else did we happen to find on this problem? We found a maximum and a minimum. Okay? Now, this question didn't ask for that, but in homework they're going to. Okay? In homework you're going to have some problems where they say find the maximums or minimums graphically. So let's just go ahead and label this one. The maximum was at x equals -1, and the minimum was at x equals +1. All right? Because you're going to be doing that sum in homework tonight. All right? Now, didn't we also find some zeros in this problem? I think in homework they're going to ask you to find some zeros. All right? Remember what the zeros are. Okay, the zeros were, let me see if I can get a new color so you can actually see it on this messy graph. These were the zeros, these points right here. Okay, so we should know how to find zeros by now. We've done that before. Now let's talk about even and odd functions. Okay, even and odd functions. All right? Okay, if a function is even, talk about even functions first. An even function is symmetric with respect to, I normally just put WRT, but I'll write it out, with respect to the y-axis. If it is an even function, it is symmetric with respect to the y-axis. The classic example is kind of a normal parabola. Okay? That thing is symmetric with respect to the y-axis. If I were to fold it on the y-axis, it would lay on top of each other. All right? So let's say that this particular parabola was moved down 3 units. Let's say that this parabola is x squared minus 3. We're going to learn about transformations later, but this thing is moved down 3 units. All right? If I were to come over here to, let's say I were to come way over to 7 and compare that to -7. Let's look at the function values at 7 and -7. What is f of 7? Well, it's going to be 7 squared minus 3. So 49 minus 3 is 46. Okay, so this y value up here, okay, and I'm kind of out of room on my graph. Okay, my graph should be coming up this way a little bit more. That y value right there is 46. Well, let's check over at -7. If I do f of -7, -7 quantity squared minus 3, well, -7 times -7 is still positive 49. It is also going to be positive 46. Okay? So over here, this value was also 46. Both the function value at 7 and the function value at -7 gave me the same y value. That is an even function. In other words, this is very important, this is my test. If it's even, f of x equals f of -x. That is my test for if it is even or not. I like to call this the test statement. Okay? Because they'll ask you to find out if a function is even algebraically, not just graphically. Okay? So, you know, let's say that I had, Let's just do one of those real quick while we're talking about even functions. Let's say that I had f of x equals x squared plus 1. Okay? And I wanted to know, is this function even? Okay? Is it even? Well, if it is even, then I know that f of x equals f of negative x. That is my test. Okay? So watch what we do. This is how we do this algebraically. You have to understand the equal sign to do this problem. Doesn't this say that f of x equals x squared plus 1? So guess what? I can put that x squared plus 1 right here. X squared plus 1. I want to know if that is equal to what I get when I put a negative x in for x. F of negative x means right here I'm going to have negative x squared plus 1. Now, here's what I want to know. Is the left side equal to the right? What is negative x squared? Isn't it just x squared? Right? A negative times a negative is a positive. So x squared plus 1 equals x squared plus 1. Great big smiley face. This thing is even. We just proved that algebraically. Okay, and you're going to have to do that in homework. Now, let's talk about odd functions. Okay, odd functions. Odd functions are symmetric with respect to the origin. Symmetric with respect to the origin. What would that look like? Well, something like this. The classic case is kind of a cubic type. One like that. Okay? And so if I have the point 3, 3 on the graph, then I also have the point negative 3, negative 3. And what is my test for if it is odd? Here is my test for if it is odd. If it is odd, then f of negative x equals the opposite of the function. Now, that little opposite on the right side, people mess that up all the time. Okay, this little thing right here, you're probably better off thinking of this as negative 1 times the function. Okay? You're better off thinking of it as negative 1 times the function. So let's see if I can find out if I can use this test algebraically. All right? Let's just do an example and say, is the function even, odd, or neither algebraically? Okay? And let's say that this is my function. G of x equals x cubed minus x. Well, the way that I normally set these up is I just go ahead and set up both tests. I set up my even and I set up my odd. And I go ahead and write the tests underneath them. If it is even, then f of x equals f of negative x. If it is odd, then f of negative x equals negative 1 times the function, or the opposite of the function. You have to take a negative through the function. That's why I write the negative 1 there. So, let's check to see if it's even first. If it is even, then the original function, which is x cubed minus x, has to equal the original function when I plug in a negative x. So let's plug in a negative x. Negative x cubed minus a negative x. We're trying to see if the left side is equal to the right. So on this right side, if I cube a negative, isn't it a negative? So this is going to be negative x cubed, and I have two negatives right here. This is going to become plus x. So is the left side equal to the right? No, it is not. Boom. No. I know it's not even. So let's see if it's odd. If it's odd, now this is where you can save yourself some work, people. Doesn't it say f of negative x? Well, didn't we find that over here? Right? There's no need to redo the work. If you did the work correctly, just recopy that. Negative x cubed plus x. All we're going to do is kind of recopy that up there. I want to know if that is equal to the opposite of the function, or what I get when I multiply by negative 1. So negative 1 times x cubed minus x. In parentheses. Notice how I put it in parentheses. People mess that up because they don't do distributive property right. So when I do distributive property, negative 1 times this, negative 1 times this, I get negative x cubed plus x. Is the left side equal to the right? Huh? Aren't they the same? These two are the same. So this function is odd. All right? Now, what would happen if you did both tests and neither of them worked out? Then your answer would be neither. It is possible for a function to not be either one. All right? And we are going to stop there for today.